Hi, this is Ms. Goodman, and I would like to go over a couple of points from our Module 3 discussion on the difference between the average salary of a certain profession and the actual salary. Now, this is a hypothetical example where the teacher's salary, the average salary would be $40,000, and the actual salary is X because the actual salary can vary. And the difference between the average and actual salary is less than or equal to $25,000. So that's the maximum difference between the two salaries. Now the first point I want to make is here. Using the absolute value symbol, these two expressions are equal. Whether we write the difference between the actual salary and the average salary, or the average salary and the actual salary, doesn't matter because the size of that difference is the same. It's less than or equal to $25,000. Now, the other point I'd like to make is how to apply Case 3 in the other appendices 2 of your textbook. Here is my absolute value inequality. How do I solve this? Case 3 is when we have this symbol, less than or equal to, or less than. Whenever we have this symbol, we solve it in the way I'm going to show you. Now, to solve any absolute value equation or inequality, the first step is to get X out of the absolute quality symbol, out of the absolute value symbol, because we want to get X by itself. So, how do we get X out of the absolute inequality symbol, out of the absolute value symbol, when we have an inequality less than or less than and equal to? It helps to understand what we have graphically, because we need to translate this expression into its equivalent expression without the absolute value symbols. Here's a graph. Our average is the middle value, right? Our average is 40,000. This here says that the difference between the average and whatever the actual salary is, any point along this line, these lines, is less than or equal to 25,000. So the salary could be the average plus 25,000 going in this direction, or the average 25,000 going in this direction. So the average minus 25,000 or the average plus 25,000. Right? So this difference could be, now remember, the difference is the difference between here and here, average and actual, and difference between here and here. This difference could be less than or equal to the size of 25,000. Or this difference could be here, this average, this difference here could be greater than or equal to minus 25,000. The difference. So it could be a negative difference between average and actual, or it could be a positive difference between average and actual, but the average in relation to here, right, is less than or equal to, and this average in relation to here is greater than or equal to. So now when you solve this, you see when you solve this, by adding, we want to get X by itself, So we need to add 40,000 here, add 40,000 to the left side, add 40,000 to the right side. We actually have 3 sides in this compound inequality. We get here on the left side 15,000, on the right side 65,000. Graphically, this looks like this. We solved for these endpoints here, right? We have the average here, and the difference between the average and the actual is of size 2,500, but it could go either in this direction or this direction. If it goes in this direction, the value of x can be up to 65,000. If it goes this direction, the value of x can be as low as 15,000. So x can be anywhere in between here. The actual salary can lie anywhere in between here. This is what we have solved.